from here, we already arrive with our partial of m. So from here, we'll get our n. So we'll extract this one first. We have negative x squared minus this one. So x times x, that is xy. Y times x, that is xy. So nakay 2xy. So you have 2xy plus, so that is plus y squared. So you have negative x squared minus 2xy minus y squared. And remember that this one will be derived with respect to your x. So from there, so we have to derive this one. So we could derive this one because they have the same variable. So you have negative 2x, so derivative of negative x squared, that is negative 2x. So here, we derive x, and your 2 and y is a constant. So copy na to ang 2 and y. Derive your x, that is 1. So derive of y, that is, if y is different with this variable x, so therefore this is a constant. It's just like minus 2. So derivative of 2, that is 0. So therefore, our n of partial of n over partial of y is just equal to negative 2x minus 2y. So if you could see, they are equal. Your partial of m and partial of n is equal. Therefore, we could say that this is an exact differential equation. So this is an exact differential equation. So from here, because we already know that this is exact differential equation, because your partial of m over partial of y, this is x, partial of x. So this is unsa. Hello. We already derived, no? So in this case also, so then we will derive. So from here, derivative of negative x squared is negative 2, and derivative of this one, because this is respect to x, so your y is just a constant. So you write your 2y. Derivative of x is just 1. Then here, if you would see, this is with respect to x, and this variable is y. So therefore, this is just a constant. This is just like your number 2. Derive 2, that is to 0. Okay? So you could use y only if you are partial of y. Okay? The same as this. So from there, just simplify it. Then, if you could see, partial of m over partial of y is just equivalent to partial of n over partial of x, which is equivalent to negative 2x minus 2y. Therefore, the differential equation is exact, and we could solve it using the method exact DE. So now, this is just checking whether the equation is exact. So after that, what you need to do is to remember again this one. So you just write this one, m of x, y. Ang different lang is you will integrate it already. This is our general solution. You just substitute it. So copy, and your dx now, imbis dx na siya, becomes partial of x. Partial of x, meaning, ang iyahang variable na dili x, like y and other variable, will be treated constant. Okay. Tapos, same, plus, and integral of xy dy equals 0. Ang different lang dyan is this one is now integrated, and the dx is now partial of x. After that, you need to just substitute it. So substitute our m is this one, no? So our m is 4 minus 2xy minus y squared equals partial of x plus your n is negative, copy ano lang nato para hindi na extra, kinina no? You have negative x squared na wala pa gi-derive, okay? So this is just extracted, negative x squared minus 2xy minus y squared. So that is for our n, dy equals 0. After that, let's continue up here. So from there, just expand this one, combine those, combine. So here, distribute the partial of x. So you have 4, move 4 outside the integral sign. So you have partial of x. That is not 2, guys. You have 2. Then, we are on x, right? So your y is a constant. So move your y outside the integral sign. So that is x partial of x. So that is x partial of x. So minus, we are still on the partial, so your y is still a constant. So move outside the integral sign, then you have partial of x. So not minus, so we have here. So this is dy, so dili niya i-consider na siya as constant because this is not an partial, this is a total integration. So therefore, we'll write it like this, negative x squared dy, continue tani, minus 2 xy dy, then minus integral of y squared dy equals integral of 0. So now, we'll try to eliminate. Okay. So, from here, we'll try on the total integral. If in the total integral, if the variable is y, and it contains another variable within the integral, then that is equal to 0. This one also is dy and it contains x, that is 0. It could only happen if your differential is partial, okay? If it is partial, but if it is total integration, then that is equivalent to 0. So this one, dy and y, okay. So let's continue. So from here, what is the derivative of integral of dx? So what is the integral of partial of x? Guys? The integral of partial of x is just like the integral of dx. So that is x. So it's just like dx minus 2y, copy. So this is power rule, that is x squared dx. So you have x squared over 2 minus y squared, integral of partial of x, that is x, then minus integral of this, that is y cubed over 3 equals c. From there, we can simplify this one. Okay. So from there, we have 4x minus x squared minus xy squared minus y cubed over 3 equals c. So you could have this one as your general solution, or you could just or you could still simplify this one. So simplifying this one is multiplying 3. So I could accept this one already. Pwede na siya. So question, Question? Any question before I proceed with another example? Wala question? Palagi mo ana ha. Okay? If no question, so I'll proceed with another example. So, another example is, di na nato isuwat lang ha, kay merag apiki na sa time. So, only have 19 minutes left. So, this is example. So, we have this answer. And let's try this one. So, in this case, so our given is not separated as m dx plus n dy. So, it is not separated. You need to transform this one to become like this. So, this one katag pa man eh. Then, if you decided that your given differential equation could be a exact DE, then you need to arrange or make it the same as your general form sa first order, first degree, DE. So, from here, what we will do is just to distribute the e raised to the power of 2x. This is just algebra. So, distribute here. It becomes like this. E raised to the power of 2x times 2y dx. It becomes like this and this one. Then, if you could still remember, dx is the top left side or the most left side. So, you put the dx on the left side followed by positive then dy. Because we want to get dy dx. So that this will be our m and this will be our n. So from there, common is dx. So it was group. After that, nag-group naman nato, this already form your your general form. Then we could derive this one and this one. Let's see if they are the same. So you put your m. So your m is this one and your n is this one. So you put it here. Now let's check. Derive this one. With m is with respect to y, so derive this one. So copy first the 2 and the e raised to the power of 2x because we will not derive that one, that is constant. Derive the y, that is 1. So this is 2e to x. This one, this is just a constant because we will derive with respect to your y. So this is just a 2, derivative of 2 is just 0. So your partial of m is just 2e to x. So for the other one, so we have partial of m over partial of x is equivalent to partial of this one, the given sa n. So when you derive e raised to the power of 2x is just 2 e raised to the power of 2x, diba? We derive sa kanunay nato ni siya gamiton sa variable separable integration by parts nato. So e raised to the power of 2x, your 2 multiply then copy. So that's how you derive exponential. So if you could see, partial of m, sorry, this is n ha. I forgot. I typographical error na pagsuwat na ako. That is n. So if you could see, your partial of m and partial of n is equal. Therefore, this given differential equation could be solved by exact differential. Okay? Na method. So by that, we will use the general solution for exact DE. So, copy the general form, but your x will be partial and the others. Then, our m is equivalent to this one. So, we copy. And our n is equivalent to e raised to the power of 2x. So, we copy. After that, we distribute your partial of x. So, distribute here, distribute here. So, by the way, this one could be moved outside already because that is not x. So, you just integrate the e raised to the power of 2x. So, integral of e raised to the power of 2x, that is 1/2 e raised to the power of 2x. That's why it's e 2x over 2. Then, this is just copied. Okay. Minus integral from here, integral of x squared, that is x cubed over 3, that is power rule. So, from here, this is equivalent to 0 for a reason we are using total integral in our dy, and our value here is